For example 6.5, we are given 4 ODEs which are second order, linear, and homogeneous. So we are asked to find their general solution. So for the first one, we are given y double prime plus 2y prime plus y equals 0. So for this case, as seen in the lecture or in the lecture 6, we can solve this using the characteristic equation. So we can get the characteristic equation from the ODE. So for this case, the characteristic equation is lambda squared plus 2 lambda plus 1 equals 0. So the terms of lambda will come from the derivatives y double prime and y prime. Tapos yung constant will be yung y function. Okay, so we will solve this characteristic equation using the quadratic formula or simply factoring. So this will be lambda plus 1 equals 0. So the roots for the characteristic equation is negative 1 repeated twice. So from the lecture, ayan, may kodigo tayo. So from the lecture, we can get the solution using this guide. So if I have two roots, so real double roots, so which is the case for number 1, so the solution will come in this form. So yung form natin will follow y equals c sub 1 e lambda x plus c sub 2 x e lambda x. So we will just substitute the value for lambda. So that is y equals c1 e negative x plus c2 x e negative x. So that is the answer for number 1. Okay, for the second problem, we have y double prime plus 9y prime equals 0. So again, we get the characteristic equation, that is lambda squared. So kung ano yung degree ng derivative, yun yung degree nung lambda. Okay, so lambda squared plus 9 lambda equals 0. So let's factor out a lambda. So lambda times lambda plus 9. So we get the roots. Lambda is equal to 0, 1. Lambda 2 is equal to negative 9. So let's look at our código, our guide. So from here, we have two distinct real roots, which are 0 and negative 9. So we will follow the format y equals c sub 1 e lambda 1x plus c sub 2 e lambda 2x. Substitute the lambdas. So we have c1 e0. So we can just write this as just c sub 1 plus c sub 2 e negative 9x. This is our general solution for the second ODE. Okay, for the third problem, the given ODE is y double prime minus 9y equals 0. So same, we get the characteristic equation, lambda squared minus 9. So take note, ito ay y function na, hindi na siya derivative. So wala na tong lambda na kasama. So equals 0. Let's factor this. You will get lambda minus 3. Tama. Tapos lambda plus 3 equals 0. So we will get the roots as plus minus 3. So for this case, we have two distinct real roots. Move natin to pababa. Oops, again, never mind. Okay, so two distinct real roots, positive 3 and negative 3. So again, we will follow this format. So kung mapapansin nyo yung format, it's essentially the same. Lambda x 1 plus c2 e lambda x. So 1, 2. Let's substitute the lambda values. So you have c1 e minus 3x plus c2 e 3x. Okay? Yun lang yun. So plug in yun lang si lambda. And then finally, number 4, we have the ordinary differential equation of y double prime plus 4y prime plus 7y equals 0. First step, we get the characteristic equation, that's lambda squared plus 4 lambda plus 7 equals 0. Now, if we cannot factor out the polynomial, we can use the quadratic formula to get the value of lambda. So that is negative b plus minus square root of b squared minus 4ac over 2a. Okay, so we can substitute. If you solve this, you will get the value of negative 2 plus minus square root of 3i. Okay, so the roots, we have negative 2 plus minus square root of 3i. So for this case, complex na yung roots natin. So we will use this, we will use this form for the solution. So ang nangyari dito, you have lambda which are complex, tapos we used the Euler identities para maging kamukha siyang ganito. Okay, so as you can see, the real part of the lambda will be in the exponent of e kasama ni x, tapos yung imaginary part, that coefficient b, kasama siya nung cosine and then ng sine. Okay, so the solution will follow the format of y equals e ax c1 cosine bx plus c2 sine bx. So our a is negative 2 and then b is square root of 3. So we have e raised to negative 2x c1 cosine square root of 3x. Sulat natin ulit. Square root of 3x plus c2 sine square root of 3x. So that is our general solution for the fourth ordinary differential equation.